So before I share my screen, so my name is Roy Tomalino. I'm the Calibration Evangelist with Beamex. My goal today is to demystify some of the things regarding calibration and have the conversation of, are you calibrating too much? In some cases, maybe. If we're talking safety instrumented systems, then that's a whole nother ball game. But also history trending. Does your calibration, does the history match up with how often you're doing it? And if your calibrations are out every single time you're going out, then that can be a problem. But the other side of that is true also. If you calibrate every year and it doesn't move at all, you can actually increase your tolerance by 50%. So, or your, not your tolerance, I apologize, your interval. So if you're calibrating annually, you can calibrate every year and a half from that point, or stretch it out even farther. But you need data in order to do that math. Let me share my screen. I have a remote controller. I have a calibrator, and again, most of you are using Beamex. Some of you are using the hardware, and some of you are using the software only, and quite a few of you are using both. And just to show you, I'll be doing some examples on the calibrator here. And as I click on the screen, you can see it actually changes on my physical calibrator. This is not an emulator. This is a live system. So I'll do a cal, and then I'll show you how to do a trim at the same exact time. I'm starting off with a temperature transmitter, and I have some leads on here for my convenience. Let me get this plugged in. And if you're already using software, then you just load it onto the calibrator and start there. But let me do this the hard way. We will hook up to this with no information whatsoever, and we'll query the transmitter and let it build itself on the calibrator. So back to the home screen. If I go to Documenting Calibrator, there's a yellow star. That's our shortcut for creating something new. And so my input here is RTD. Next page, current is my output. All right, we have a secret button on the top left. If I hit this, one of the options is Get Mapped Values. Let me hit that. And depending on where you are, that the values in that pull-down menu are different, depending on what screen you're in. But chances are, if you're looking for something, it's in there. So you can see it coming over right now. Little progress bar. On the very top, all right, it pulled over our tag name, which is TT555. It's RTD. It's in Celsius, Platinum 100, 385. Current is the output. We are providing loop power with the calibrator. It also brought over the range, -10 to 800 Celsius. It's linear, 4 to 20 out. We'll leave this as a 5-up test, so that's fine. We'll leave on stability check, and I have it set to automatically grab each test point after a 5-second delay. Once it stabilizes, it'll count down 5 seconds and then grab it. 0.5% of span tolerance. I could go in here and use an actual engineering unit, like plus or minus 2 degrees or a 1/4 degree, but I'll leave it as a 0.5% of span. It brought over the make and the model. There's no sensor serial number. That would be the temperature probe itself. Here's our position ID, which is the same thing as a tag ID. And device ID and device serial number. All right, this all looks good. Let me hit check. So I'm out in the field. I've hooked up to this temperature transmitter, and we're about to run a calibration. But I just wanted to show you that if you already had this in your software, you could have loaded it from the software to your calibrator, and you'd already be at this step. But I told you I was doing this the hard way. Now, as a technician, you know what? Let me just back out of here. So now under Documenting Calibrator, I have this tag, TT555. So if I go out on site and I click on it, even if I'm new, this shows me the details behind it, the input, output. It shows me where to plug in for the input, where to plug in for the output. Let me hit check. So this is a transmitter only. There's no temperature probe. Now, I haven't started it yet, but we're already sourcing -10 and we're getting 12 or 12, we're getting about 4 milliamps, and we're calculating the error right now, live, above the graph. So the blue lines represent our tolerance, which happens to be 0.5% of span. And we have a 0 here in the middle. So let me hit start. Now the bottom right is the test point we're going after currently. And you can see in the middle on the bottom, once it stabilizes, it'll count down those 5 seconds. And then grab the test point. The top left is what we're inputting the transmitter, and the top right is what we're measuring as a current. So we're getting a number for error, but we're also getting a visual representation. And it's green, which means it's passing. It's in between the blue lines. It's not perfect. Okay, it passed. Negative 0.328 is our maximum error. If I wanted to, I could go down a page. Well, it's calibrated by me, Roy, and I could put in a note here if I wanted that as part of the record and part of the calibration certificate. And I arrowed down again. So this is the graph, and I can go down to the final page. This shows all the raw numbers that I don't have to write down. So I know that there is a best practice that recommends you have an automated system with documenting calibrators and that you are paperless, but you do have some freedom in what tools you choose to use to meet that. So this is all grabbed. Let me save it. And I'll save it as found. I could save it as both and be done because it did pass. But I want to show you how to do a trim on this as well. So let me save it as found. And now I'm back to, well, I could do my as left here, or I can go grab a communicator and then I could do the trim there, or back to the secret button. Up on the top left of the touch screen is Start Communicator. You may not have known this, but there is a full-blown communicator built right into the MC6 calibrator. So it's connecting, and we'll see the menu structure, and we'll be able to run the methods in order to do a trim. Okay, main menu. Here's our tag on the top. I just clicked it. Now green represents a measurable variable. So we could also measure the digital HART output as well. You could display that if you didn't want to do the 4 to 20 milliamp output. You would calibrate using the digital representation, which would be here, the temp and degrees C. You would calibrate that if you were using that to control your DCS, your control system. But most tend to use the 4 to 20 milliamp to drive that control system, but you can do either. If I wanted to rearrange this, I would just click here, click on LRV or URV, change the value and send it back. But I don't want to do that. I just want to do a trim. So device setup, all right, input, output, device info, diag service, that's what we want. Now there is a loop test. That just it tells the transmitter to send out 4 milliamps or 20 milliamps or another value that you say. 90% of the time, the answer is within a sensor trim. The sensor is the front half of the transmitter. So we have factory trim, which we could put it back to factory, do a 1 point. I'm going to do a 2 point. I want to do an upper and a lower trim. Sensor trim offset gain has to be reset to factory setting. All right, I'm waiting for a check mark. Okay, apply low input value. Well, the bottom right is already set to -10, and we should be getting exactly 4 milliamps, and we're not. 39984, well, and change. So let me hit check. Now the message up on top is what would show up on your communicator, and then you'd have to have a separate meter because you need to measure the milliamps as well. So let me hit check here as well. So it's doing both things. It's showing us what the instrument is saying for the method. Enter applied value. Well, our applied value is -10, and I can click here and write in -10, but here's a shortcut. Over on the right side, the number 1 will do a copy window 1, and it'll paste it in there. So let me hit that. So I just copied -10 and pasted it in. Now let me hit check. And watch the bottom right. See if that boarding offset too large. You know, sometimes on this cam strip transmitter, I actually have to do this a second time, which is curious, because I wouldn't have thought that offset was too large. Let me run that again. And this is all dependent on the instrument itself. And if I have another difficulty, I'll just run the factory trim method. Apply low input value. All right, I'm hitting check. Press OK when it's stable. It is. Okay, so I'm going to hit -10 again, and now we'll hit check. All right, see there, it's happy. So oftentimes on this particular transmitter, I had to run it a second time. So, all right, now in window 1, it says apply high value. The blue numbers tell me that I can edit this. My high is 800. All right, check. So now I'll wait for this to stabilize. I'll hit the check mark because I know there's another message coming up. Press OK when it's stable. I'm looking at it, and you know, it actually looks stable. So I hit check. Enter applied value. Again, I'll hit this 1 on the side, which will copy window 1 and paste it up there. And now I'll hit check. So again, watch the bottom right. You seeing a change? Now we'll see that. All right, so the sensor trim is done. And I can go up folders to go up 1 level. So here we can do a D to A trim. That's on the back half of the transmitter. So on the front half, the sensor, we have an analog input and a conversion to digital. That's your digital PV that you can send to the DCS or read it. Once you have that digital, we have to, well, the transmitter has to reconvert that back to analog to give you a 4 to 20 out. So if we still have a problem, we'll come back in here and do the D to A trim. So let me just hit X. So I'm back out to the transmitter. All right, so our high is perfect. Let me just change this to -10 and see what we're dealing with on the input. Okay, that's good as well. So I am saying we're not going in to do that D to A trim. Let me hit start. We did our as found. It passed, but it was farther out than I wanted. And we trimmed it. And now we're doing our as left. So the calibrator is in automatic mode. And while I'm talking, if you do have questions, this is a live scenario and there aren't any slides. This will be driven based on your input. And my plan is to do this, and we'll look at a calibration certificate. So it's just about done here. And after this will be a pressure transmitter. But if you do have questions or you want to see something specific, put that in the comments mode. If it fits for that spot. Okay, pass. So now our error is -0.018 maximum. All right. Now under note, I don't need to put anything on here, but I'm just going to put in performed trim. Well, let me just say sensor trim. Okay, and now I'll hit check. So this will be on the cal certificate. Arrow down again, this is our graph, and these are the raw numbers. Again, I don't have to write these down, but I'll just hit save. Combine with previous as found, good, and we'll save this as left. Great, I'll hit check. Now we're back here again. The calibrator doesn't know if we need to do another trim and to do a final as left, but we're done. So let me go back and just show you something. We have this test, but now there's a button that has a magnifying glass, and that's to view results. So if I go down to the graph, this is how we left it, but I can hit that secret button again on the top left and do show older result. So watch this. This is our original. Let me hit the secret button again and then show newer result. And now you're seeing how we left it. We can see both of those overlaid on top of each other in the software in a calibration certificate, which I changed my mind. I'm not going to show that right now. So just debating. Let me go back out here. All right, so I'm just exiting back out. I can keep hitting the X, or I can hit this home button with a green circle, and that'll take me back to the home screen. But if I go to documenting calibrator again, now there's this instrument, but it has a check mark, a green check mark. That means that it has been tested and it was left in a passed condition. If we left it in a failing condition, it would have a red X in that box. So I think what I'll do is perform a cal on a pressure transmitter. So I'm holding this up on the camera. This is a Rosemont 3051 differential pressure, and I've got a couple leads for the output, just again for my convenience. But I'll be hooking up to the high side of this transmitter, and I've got the low side vented to atmosphere. So I'll disconnect my temperature. And while I'm doing this, on the temperature, we just calibrated a temperature transmitter. It is possible to perform a loop calibration. We could have sourced the temperature input we're simulating. So with an RTD, we're actually sourcing resistance, which simulates a temperature probe. You could have the final step be reading what the DCS says and actually punch that into the calibrator as well and do a loop. Or you can go one step farther. You can add the temperature probe to the loop as well. And for that, you'd need a temperature block to source physical temperature. And many of you do have temperature blocks that you use with the calibrator. The calibrator can control a temperature block so that it's telling it to go to -10 and wait till it stabilizes and grab the measurement, and then it'll tell it to go to the 50% or to the 800 degrees, however many test points you put. So you can automate a temperature calibration completely using your Beamex calibrator and your temperature block, as well as a pressure controller. So some of you have a pressure controller as well, a Beamex pressure controller that you hook it up to a pressure source like a nitrogen bottle, and you say go. And the MC6 tells it to hit 0, 25%, 50%, and it changes the pressure live. You don't need to use a hand pump. So pressure controllers and temperature dry blocks can automate your calibrations, and you can do loop calibrations with those. So I'll be doing this. I have, again, I'm showing this on the camera. It's probably pretty small for this, but I have a 3-legged pressure hose. There are 3 hoses with a union in the middle. One will go to the instrument on the high side. I'm trying to do this without the hose actually touching my keyboard and deleting me. And I'm using, these are all standard connectors that come with your calibrator. They're all tool-free. And I'll hook this up. I know which pressure port I'm hooking up to already, but drift data? You know what? That's actually within the software itself. So the calibrator, no, but once you unload that into the software, yes. So here's an item where we have 10 years worth of data. And if I right click this and just do what we call a history trend, this plots the maximum error over time. So here you can see whether it's drifting upwards or downwards. And there are the blue lines here. I'm not bringing it up under a report, which would be even prettier, but I just went for the quick show on here. So this does show drifting. And this is the data you need to determine if you're calibrating too often or not enough. And if that doesn't answer the question, just put another chat in there. Good question. Okay. The pressure transmitter, I'm connecting the output, the plus and the minus, up to the calibrator right now. And I'm still in documenting calibrator. Yellow star, again, that's how we add something new. So I could load this from the software, but again, I'm doing it the hard way. This one is not RTD, this is pressure. I'm gonna leave it on 2C and it's set up for PSI here. Let me arrow down, it says current. All right, so back to the secret button, top left. Get mapped values. So we're starting up the HART modem, and this works for Profibus and Foundation Field Bus as well. So this is also a communicator for Profibus and Foundation Field Bus for those of you who have those. But you do need to make sure to spec those when you get your MC6 unit. So while it's coming over, this is my pressure pump, and this is it does a vacuum to about negative 13.7 psi, and it goes up to about 500. All right, it's coming over right now on the screen. So on the top, it'll give us our tag name. All right, it changed from no name to PT145. So it changed the unit from PSI to inches of water because I just read it. But now, let me go down and check out. So it's 0 to 145 inches of water. So let me go back up. And the port, I need to make sure I'm picking the smallest pressure port that I can that will still be okay with the pressure that I'm about to measure, because we want the best accuracy we can get. So my smallest one is up, so this one measures 800 inches of water, but my smallest one measures 160. So that is closer, and it'll give me a better uncertainty ratio. Let me choose that one. I'm in gauge mode. If I were calibrating in absolute mode, I would just choose absolute, and then I wouldn't have to do any fancy math. It would just do it for me. All right, in measurement, we're supplying power 0 to 145. Now linear, okay, that doesn't come over on the HART. And so I know this is a square root transmitter. And it would be pretty quick if I didn't change this. Usually for a demo, I don't even change it until we see what it looks like. But 4 and 20. We'll leave it as a 5-up test strategy. Stability check. Let me take that off just for speed right now. I still have a 5-second delay. Our default is still a 0.5% of span. All right, my resolution on the error is 3 decimals. And it brought over the sensor serial number. So on a pressure transmitter, there is a sensor inside the transmitter. It's that capsule. And it brought over the serial number of that through HART. So here's my sensor serial number. Now the location isn't stored in HART on this transmitter. So the location I could put in, let me just say tank 11. Location is how you help your technicians find what they're looking for. All right, it's a 3051C. Arrow down one more time. All right, my position ID is PT145. It's batch level, and there's my device serial number. So the previous serial number was for the pressure sensor, the pressure transducer inside the housing. And down on the last page is my device serial number. So this is the serial number for the complete housing. And I'll hit check. So I just built the tag from scratch with minimal typing, just doing get mapped values. And I know there are a number of you who are using the older MC5 calibrator, and this can do that as well. This can bring that in the information and build that tag for you. It just doesn't have a complete communicator built in. It has a partial. All right, 0 to 145 inches of water in, 4 to 20 out, square root. Let me hit check. So I gotta connect my pressure hose to my pressure pump. So this is where you could have a pressure controller in your shop and not have to worry about providing pressure and let it just do everything. Again, some of you do have that. All right, I'm opening up my vent. So the first thing I'll do is on the bottom right is a 0. This 0 is the pressure transducer in the calibrator. And I'm hitting 0. So you should see the upper left hand change over to all zeros. And it looks like I'm pretty off, 4.77 milliamps. So my 0 is going to fail, my 0% test point. Let me hit start. So it's stable, it's way out, but it is stable, so it's counting down 5 seconds. All right, so my first test point failed. Let me close my vent. And I have this set up to give me a gray bar of plus or minus 4%, and I'm just letting go. I'm getting it into the gray area. So the bottom right is my actual target, but I told the calibrator to visually show me plus or minus 4%, just to give me a target, because we don't have to get exactly on that value because the error is based on a calculation of the input against the output. Now, if you are in one of the nuke stations and you are required to be on that test point, then that's a different story. But for the most part, this will suffice for all pressure applications, unless your SOP says otherwise. Okay, I just went over. So I went over, and so technically I could back it down into the gray area, but what I should do, I'll cancel out any hysteresis if I do that. Let me actually crack the vent and bring it down below, and I'll take it back up again. And I could even force accept this right where it's at. All right, so it actually landed in the gray area, but I quickly brought it back out. So now I approach it from the bottom again, going up. I'm doing a 5 up, and now I'm just doing the fine-tune knob. And once it stabilizes, 5 seconds. Okay, so we failed. All right, so we're 4.8 something percent of span off. And if again, here's our note. And if it was calibrated by somebody else, I could come in here and change the name. Let me just hit X though. All right, here's my graph. So it was off at the 0, and these are the numbers. So red would be failing. So I just click the disk. As found, that looks good. All right. So actually the upper end looks fine. Let me crack the vent and take it back down to 0. So before we do our as left, we have to fix this. So again, secret button, top left. Start communicator. And it feels like the more people that are watching, the slower this goes. But it's completely dependent on the speed of the transmitter. There's literally a microprocessor inside the transmitter that's communicating and sending information back and forth. And the more advanced that it is, the more fields it could have, which takes longer. Any moment. Okay, we're connected. So our only choice here is online. Now yellow with the little paper folded on the end means that it's a folder and we can go down. So I'll click it. Now I have 3 folders: overview, configure, service tools. So if I wanted to change how it was set up, I could go in here to configure, but I want service tools and maintenance. This varies depending on what manufacturer you're looking at. Sometimes even different models within manufacturers, it's different. But if you mess up and go to the wrong place, just do the up folder to take you to the upper level. If I hit the X by accident, it'll dump me out of the communicator and I'll have to go back in again. Okay, pressure calibration. This is the sensor trim. Analog calibration, this is the second half of the transmitter. This is the D to A trim. Okay. And so I'll click pressure cal. Do I want to do an upper, a lower, or a 0? Well, we know our 0 is off, but I want you to resist the temptation to do a 0 trim here. And why is that? Well, according to the manual on a 3051, you perform a lower trim and then the upper. I've done it the reverse order. I've done an upper trim and then a lower trim, and it messes it up. I have to go back up and redo the upper trim again, usually. So 0 trim is for when you go out and install the transmitter, and depending on the orientation, that'll have pressure on the oil inside that housing and press differently on the pressure transducer. So once you install it, maybe you install it at a weird angle, then you 0 it. The upper and lower literally changes the range, and the 0 only shifts it. So I guess the upper and lower will change one or the other independently. But if you 0 it, you have the same range, and then it'll only shift the range so that the 0 matches the 0 point. So that's why you need to do a lower and then an upper trim, and only do a 0 trim when you install it. And once you do install it out in the field, if you had to take it out, you can run a 0 trim and walk away. You don't have to do another calibration when you zero it. All right, I have 0.2 seconds dampening, and I want lower. Okay, warning, loop should be removed from automatic control. This is a default message from the device descriptor or DD file inside the instrument. This is not a message from Beamex. Okay, so I have 0 input. And I do have a fan running here, a ceiling fan, so it is changing my pressure a little bit. So I could shut that off if I wanted to, but hopefully you're all okay with this. Let me hit check. Select pressure units, inches of water. That is correct. If it was different, I would just click this and change it to the proper unit. But let me just hit X. I don't want to change that. Apply low pressure. All right, it's applied. Let me hit check. Press next when it's stable. So I'll hit check. And check is the same thing as next or enter or OK. So that all means the checkbox. Enter applied pressure value. Well, I could hit this number 1 again. I'm going to get that. All right, that's actually what it is. And now I'll hit the check mark. So watch the bottom right. So I just told it, you know, that was a big jump. We may actually have to do that one a second time. But it changed a lot. So we're now within a 0.08 milliamps. All right, I'll hit check. Lower trim succeeded. And return back to automatic control. You know what? I want to do that again. And there's red lettering on top in the screen. And anytime you see that, we are waiting for the processor inside the transmitter. So you just have to wait when you have the red lettering. If I press buttons, it's not going to do anything. You're just going to be building up button presses in the buffer and it won't be happy. So let me do this lower one more time. I want to see at least 399. Let me hit check. So 393. All right, so there's something else making it off. I've done this twice now. All right, let me hit check. So we'll do the upper trim. All right, click on the upper method. Warning, loop should be removed from automatic control. Well, it's on my desk, so it's removed. Pressure units, that's good. So I'm going to close off my vent, and it says apply high pressure. So I'm just doing a slow squeeze on this. This pump is, well, it's designed to go to 500 psi, and in reality, you can hit 600 with it. And I'm just doing a small inches of water transmitter, but if you're gentle, you can use a pump that's too large for what you're doing. Now, I'm at 145, and I overshot it a little bit. But I'm going to let it stabilize. With pressure, you should let it stabilize. Even the temperature on the pressure hose can change your pressure. Now, I would give this maybe a couple minutes, but for the sake of time, I'm not going to. Let me just take and I'm not grabbing the pressure pump. I'm just going to move the fine-tune knob. I don't want to introduce any more variables. Okay, so again, I'm still a little high. So here's a secret. So I know that I'm high, and that's okay. In fact, I might be a little bit low. But we're calibrating. The transmitter will get the measurement value of our output and adjust it appropriately for our input. And you might see a little squiggle or a tilde, and that means that it's not stable. Okay, so I'm going to take this and hit my check. Press next when it's stable. All right, it's stable. Now I'll use my shortcut key to copy window 1 up there. So I'm measuring 144. Now watch the bottom right. All right, it just shifted. But I am not on exactly 145. You know what? If I take it up, so this still isn't right. At 145.05 something, I should be closer to 20. It says remove pressure, and I'll hit OK. Upper trim succeeded. And I'll hit the check mark. All right, so now I'm just waiting for the red lettering to go away. Zero trim is not what I want. I'm going to show you something. I know I need to come back up here. Let me do up folder. I think I need to run an analog cal. But to prove it, let's go here. Let me hit the X. I'm just going to bomb out of communicator mode. And I'm in here measuring. Okay, so at 100%, I have almost 0.5% error. So I just vented the pressure pump. And I'm off here too. So there are two places to trim on a HART transmitter. There's a sensor part in the beginning. That's the analog to digital conversion. Then there's the second half. And that's the digital to analog. So, all right, back to the secret button and start communicator. So having seen those numbers and they weren't as good as I thought they should be, I would have done the analog trim right there without leaving. But I wanted to show you the graph and how to troubleshoot this. So I mentioned before, 90% of the time when an instrument is out, I go in and do the sensor trim and it resolves it. And as soon as I tell you to skip the analog trim, then that's when we have to do that as well. So there's something to be said for maybe you just do both of the trims while you're in. And I don't know if you have specific SOPs that tell you to do one or to do both. So let me go back online, service tools, maintenance. So I went to pressure cal before, that's the input side. Analog cal is the D to A trim on the output. And this is what I would have just done while I was still in here. So a digital to analog trim, yes, so check. Warning, loop should be removed, it is. Connect reference meter. Again, this is a message for a communicator that can't measure current. So we're actually measuring current right now, so we have a reference meter. Setting field device output to 4 milliamps. This is telling the transmitter to output 4 milliamps regardless of what's on the input. Let me hit check. So it thinks it's outputting 4, but we are measuring 3.9399 milliamps. So it says enter the meter value. What are you actually measuring? So I'm going to do the shortcut button number 2. This will copy window 2 and put it up there. We're actually measuring 39399. This tells the transmitter, I'm measuring this. You are short, so you need to increase the output. Let me hit check. So watch the bottom right. Okay. It just got to within a microamp. And I'm going to say that's close enough. So field device output 4 milliamps equals our reference meter. Yes. So let me hit check. If it was no, I would actually click this and choose no and then hit check. But I'm going to leave it as yes and just hit check. Now it'll set the output to 20 milliamps. And notice that window 1, we're not providing any pressure, but yet it's outputting, well, almost 20 milliamps. But again, we need to fix this. So we will use a shortcut, and I'll tell it, you're really putting out 19.98. And it's changing to 799, but it's okay. And you need to fix yourself. So let me hit check. And then watch the bottom right. Okay, now it's fixing itself. Let me hit check. So that one's like 3 microamps off, but that's fine. Most meters can't even measure a microamp, so this is okay. Now we're just waiting for the red lettering to go away. So again, if you have questions, put them in the chat and we'll bring those up. And I think after this, I'll unload these 2 tests and show you what they look like on a calibration certificate. And we'll see where we go from there. I'm not going to keep talking just to talk, but if you guys have specific questions, then I'll be happy to answer them. All right, I'm done in here. Now we need to do the as left. So for that, I do need my pressure pump. And let me hit the 0 here. All right, let me hit start. So it's moving a little bit. This is a square root transmitter, which means our 0 point is, it's almost like straight up and down as we leave 0 and go out. So let me close the vent. And I'll start taking it up a little bit. Notice, you know what? Let me back down again. My output is not changing at all. Let me close my vent. And I'm up to a 0.18 inches of water, but my output is still sitting at 4. This is due to clamping. I can't think of the actual term, but you can set this inside the transmitter so that you don't, so that it holds until you reach a certain point. And this is why I recommend using 1% on the first test point of a square root transmitter, especially if you don't have that type of clamping. So as I increase pressure, and I'm just doing the fine tune knob, we get to a point where, okay, now it's actually not clamping the output anymore. And I'll just gently squeeze on this thing. I could use the fine tune knob. And I just want to get it in the gray area, and I'll let go. All right, see, the error is really, really good. Now, it looked horrible when we started. And after I did the sensor trim, it still looked horrible until we did the D to A trim. So again, we're calculating the output measured milliamps against the sourced measured pressure. And that's how we're calculating the error. So we don't have to get it exact. And this is one of those things that don't do more than you have to. Even the number of test points. Do you need to do an up down or a 5 up down? And in some you might, but a 5 up down test in many cases came from pneumatic instruments, and they had horrible hysteresis. In fact, on some pneumatic, you would have it okay on the 0, 50, and 100, but then the 25 and 75 would be off. So that's why we had to do 5 up. So on many digital transmitters, it's like this one, if I do a down, it's really close, and there's really, the hysteresis is so small that I don't bother even doing it on this. Again, your mileage may vary. Depending on what process you're doing, you may need to do that down. Okay, error is great. So I could put in here notes that I did a sensor trim and a D to A trim. There's my graph, and these are all the numbers. And let me save it. So I'll save this as left. Okay, so I'm done. I'll show you a calibration certificate, and then I will stop talking, okay? First, I need to disconnect this viewer because otherwise it's tying up the USB port. So I need to receive USB. There's my calibrator. I'll hit connect. So now it's reading the calibrator, and I'll select everything. I have it set to create the instrument if it doesn't exist. I don't think I have a PT145 in here. There's a 145J, but I don't have a PT-145. So it will create it because I have this checkbox, add missing instruments to database. And then I have it set to delete them off the calibrator when it comes over. So the other one I have, but it will just bring over the new info. So let me hit receive. All right, it created PT145. Now it's telling me on my temperature transmitter that output loop supply was set to on, but now it's been changed to a HART compatible 24 volts. So anything that's different, if it's already in your database, it'll inform you that, hey, this field changed. It was this, and now it's this. Do you want to update the database? So I'll say yes. Go ahead and update it with my new info. And I could individually find these tags. Let me just do a search on what was calibrated today. Oh, I can just click the today button on the bottom. Let me hit apply. All right, so those are my 2 tags, and I can look at those individually. So it created this PT145. Here's my test data, but what I want, let me right-click all positions and print certificate. Oh, you know what? I just want to do the last test results. So let me cancel that, and I'll do show calibration history. Let me deselect this, and now it will only show me the last test result for everything in my list. All right, there we go. I'll hit preview so everyone can see it. And again, once I show you this, I'll give you an overview, and then I'll stop talking, and we'll bring up any need for questions. So I have 3 pages, and my first one, before I zoom in for you to see it better, just imagine your logo up on the top, and there's information regarding the test. There's the graphical representation, and then there's all the raw data down below, including who did it. And there's a spot for an electronic signature on the bottom right. Let me zoom in. Okay, so our position, the location, and I have some blanks. Remember, I created this from scratch right in front of everybody, so there are a couple blanks in here. All right, here's my input range at square root 4 to 20. My tolerance was 0.5% of span. This is pretty cool. Calibrators. It says it was calibrated using this MC6, this pressure module, with this serial number and this due date. This is what makes your calibration traceable up to the National Laboratory Standards by confirming what you used to calibrate it with. And this all comes over automatically. In case you didn't know, Beamex is the only calibration company that makes their own calibration hardware and software. So you have a huge advantage with that. So we're able to pass along this info easily. All right, here's our graph. I had it set to shrink the scale. So our red was way off the chart. The blue lines, again, that's our error limit. And our green is how we left it. So that was far better. Okay. So there's all of our data. Let me go down to page 2. Temperature indicator. All right, so this is our temperature. And you can see there's lines above and below each test point. That's the calculated uncertainty of the test standard that was used. So the MC6 is putting those bars. You can turn those on or off. It's just a checkbox in the options. Let's see, what is the final... Okay, so that was a previous one. Apologies. All right, so this is the temperature that we started off with. The red is where our as found was. It still passed, but I wanted to show you how to do a trim, so I did it anyway. And we did a trim and then left it in that green condition. And a second page, I shouldn't have actually had that in there, so apologies. And here's our calibration note, performed sensor trim. All right, close print preview. In fact, I can just remove that one from the list, and then I could do a preview or a print. So now I don't have that second page 2. I only have pages 1 and 2. I know what you're all thinking. Please, no. Serious? Oh, yeah, I can see, yeah, especially you in the back. Yep. I wanted to show you, for those who aren't using the MC6, what that looks like. It's this. And there's also an intrinsically safe option for those who need it. And I mentioned a temperature block before. So a number of you have Beamex temperature blocks, and this is one that happens to have an MC6 built into it. But this will automate calibrations with temperature, but you don't need to have a calibrator built into it. You just need to have a serial port on the front and connect your MC6 to it and let it take control. And then just have the driver. And then finally, some of you have this POC8. This is a pressure controller where you set it on a bench in your instrument shop, and The MC6, you put the info in there, what the test points are, and then you hit start, and then it tells this box to regulate to whatever pressure it's supposed to be at, and then it grabs all those test points automatically. And it'll even include that this POC 8 was a test standard that was used. So that's the gear that we were talking about. I hope that I've demystified some of the things that you can do.